Okay, welcome back. It's time to go on. The next speaker in the session is Dr. Jörg Riedel von Landesbetrieb Mess- und Eichwesen Niedersachsen in Hannover. So we are entering the field of legal metrology and of hydrogen infrastructure. The talk is entitled Options for Conformity Evaluation and Verification of Hydrogen Fuel Dispensers with Metrologically Traceable Test Equipment.
Yeah.
It's up to you.
Yeah, thank you, Mr. Melzer, for the kind words. So before I start, let me present shortly the Mess- und Eichwesen Niedersachsen, so my employer. We call it shortcut MEN, and after that I will switch over into the rule of hydrogen fuel dispensers as part of the mobility transition and their importance for the energy transition. And that point deals about the political strategies and goals to set a framework to enable the energy transition. And the framework contains the fuel cell vehicles, and to use fuel cell vehicles we need an infrastructure of dispenser, and in order to operate dispensers in Germany, the rules of Measurement and Verification Act must be ordered, and that bring us to legal requirements for hydrogen fuel dispensers and how to validate, how to prove the dispensers respective to the requirements, which kind of options we have. So that's the next point, the main topic, options for conformity evaluation and verification of hydrogen fuel dispensers. And there are only two options, the gravimetric method and the dynamic method, and I would give you some ideas and overviews about the measurement principles, the devices and the circumstances in operation, and also some informations to the measurement uncertainties before I end with a summary. So MEN, Mess- und Eichwesen Niedersachsen, is the verification authority of Lower Saxony State Enterprise, and we are 150 employees roundabout and work at 5 operating centers with 9 locations. We do approximately 75,000 tests per year on 150 different types of measuring devices, and it doesn't get boring. So there are various institutions and governments which create goals and strategies for the mobility and energy transition. And the big one is the European Commission, and they create the Green Deal. It is a package of political initiatives for Europe's climate neutrality by 2050. And of course, the German government creates also strategies, a strategy of system development for climate neutrality by 2045, a strategy of transformation for carbon-free companies, and there are various strategies and laws of the federal and state governments for climate protection on hydrogen and electromobility in Germany. And all these goals and strategies and laws form the framework for the mobility and energy transition. And the framework contains the fuel cell vehicles as part of the mobility transition. And to use fuel cell vehicles, we need the infrastructure of the dispensers. And that infrastructure has been under construction since 2016 by H2 Mobility. And H2 Mobility is a consortium of different companies, and the purpose of H2 Mobility is only to build up the infrastructure. And up to now we have 69 dispensers for cars and now are 14 under construction. And for trucks, we have 50 dispensers and 21 under construction. And when we look on the quantity of hydrogen, look at the right diagram, we see an increase. And the reason for that is that the number of the trucks increase as well. So Hyundai plans approximately 1,600 trucks placed on the market of European countries until the end of this year. And so the story continue, and I'm very glad about that, because the numbers of the whole dispensers are quite less. Yes, I told you, when you in order to operate dispensers, you have to think about the Measurement and Verification Act, and we call it Mess- und Eichwesen in German. The shortcut is MESSEG, and this act is always applicable if commercial traffic of goods takes place on the basis of measured values, and that includes also in the trade in hydrogen, and the dispensers and the measured values used for trading in hydrogen are subject to the provisions of the MESSEG. So according to paragraph 6 MESSEG, the manufacturer must demonstrate the conformity of its hydrogen fuel dispenser with the essential metrological requirements on the basis of a module concept. And for this, independent notified bodies prove the conformity. And MAN has also a notified body to prove the conformity of the dispensers, and that will bring us to the question how we prove, so to the metrological testing procedure. And for the use, we can read the paragraph 37. According to this paragraph, hydrogen fuel dispense may not be used on non-verified after the calibration period has expired. The metrological test must be repeated. So the test period is here 2 years. And I would describe for you and will show you how we test and how does it work. So it is quite easy. What does the metrological testing of a fuel dispenser consist of? So measurement is always a comparison, and we do the comparison of the indicated measured values of the same quantity of hydrogen measured by the dispenser and by a traceable test device. And then we compare both values, calculate the relative deviation, and check up if it is the calculated value between both limits, here 2, +2 and -2%. And the measurement uncertainty must taken into account, and according to the rule, the uncertainty must less or equal ±1/3 of the limit. So the limit is 2%, so the maximum value for the uncertainty which is allowed is 0.67%. Okay, now I would present how to build a test device like the gravimetric method. And it is quite easy. Therefore, you have to use a balance, of course, and on the balance there's a container, and the container is for the collection, to collect the quantity of hydrogen, and after that process the mass will be measured, and then we do the comparison and do the same process. And here you can see a realistic situation. So on the left side, you see a picture of a dispenser with two nozzles, one for 350 bars to refuel trucks, and the other for 700 bars to refuel cars, and each nozzle to each nozzle belongs different flow meters with different size. And on the right side you see the trailer which were built up by METAS. METAS is a National Metrological Institute of Switzerland, and when we look inside the trailer, we can see the gravimetric test device. It is not clear where the balance is, but it must be on the bottom, and there are the load cells, but they are covered. But you can imagine the containers to collect the hydrogen in black color. This device has 6 containers for filling, and when filled hydrogen, the filled hydrogen must be released into the atmosphere after the measurement procedure, and it takes approximately 1 hour or longer. And another disadvantage is that the measurement conditions are not comparable with those during refueling under the real process during the refueling of a car. And we see it as a complex equipment. That means a lot of maintenance and servicing. But there's a big advantage, the low measurement uncertainty. And it is less or equal than plus minus 0.3%. And this device is a fundamental device. So it is also good to do traceability, maybe, and we will see for what we can use it. So this picture shows us the dynamic method, and this method use also the MAN, and we use Coriolis flow meter, which we put between the dispenser and the car or the truck. So we measure the same quantity of hydrogen during a refueling process. And that means that we do it under the same condition, and it is quite easy. The calculation is the same. And you can see here it is very easy. So in the middle of the right picture, you see the metallic box. Inside that box is a Coriolis flow meter, and on the left side you see a flexible pipe in black and a black nozzle, and that nozzle came from the dispenser and is in connection with a metallic box, of course. And then there's another flexible pipe in blue, and this pipe comes from the Coriolis meter and brings the hydrogen to the car. And yeah, the measurement takes only 6-7 minutes. The whole process is be done in 2 hours, and that's quite easy and simple. Yes. Yeah. I told you the vehicles which we use serves us as drain, and the testing is under real measurement conditions, and that's a little bit disadvantage, but it's quite enough. Measurement uncertainty is less or equal, more equal, plus minus 0.67%. But it is enough to do the validation of the dispensers. And what we need is the traceability, of course, and therefore we need the Physikalisch-Technische Bundesanstalt, PDB, in Braunschweig. Braunschweig is in Lower Saxony, close to us, and they are they built up a standard. They started last year or 2 years ago, and I hope they will finish it in the next year. But now we have only the gravimetric standard of meters, and we use it to do a comparison between meters and our dynamic reference mesh system. We call it reference measurement system in English. And therefore we use a hydrogen fuel dispenser of Zentrum für Brennstoffzellentechnologie in Duisburg. And they have a plan to develop this technology, but there belongs also a dispenser. And this dispenser was used by Metas, CESAM, NMI, and TÜV Süd. These companies and institutes, they have altogether, each company has a gravimetric device, and they use that dispenser to compare their devices. And we stepped on that train and do our measurements, and I call Metas, can you give me your results? And the guy there said, yes, you can get it, and here are the results. The blue points are from Metas, the orange from our dynamic RMS device, and the beams overlap, so our measurement system is valid. And that makes me very happy. So that means that we can use it to do the validation of the dispensers. Yeah, I reached the summary. I told you something about goals, strategies, and laws, Green Deal, and a framework, and part of that framework is e-mobility with hydrogen, of course. Therefore, H2 Mobility developed an infrastructure of dispensers, and according to paragraph 37, hydrogen fuel dispensers may not be used non-verified, and that brings us to option for conformity evaluation and verification of hydrogen fuel dispensers. There are two methods, gravimetric methods and method and dynamic method, and both method and devices are comparable. And so I reached the end. Thank you for listening.
Thank you very much. It's nice insights into the legal metrology of hydrogen to make sure that the amount of hydrogen that is bought is actually the same, or actually the one that is purchased, just as we have it for gasoline, right? That's the idea.
No, I understand.
It's the idea to make sure that the amount of hydrogen that is purchased is actually true, just the same way as we have it for gasoline already.
Yes, it's the same way. It is the same way, but the pressure is much more higher, and there's the pressure is higher, and the hydrogen is in another condition. So when we do it by natural gas dispensers, the natural gas is very cold, and here the hydrogen is cold. First in the dispenser it is cold, minus 40 degrees, and in the car it is close to 20 degrees because of compression.
Are there any instant questions from the audience? I have one more. You said for the gravimetric methods, the testing conditions differ from the actually refilling conditions.
Yes.
Can you specify what are the differences?
Yeah. Not working. Okay. when we use with a dynamic method, we use the car as a drain, and there's a connection between the car and the dispenser. The car and the dispenser are talking together. The dispenser have to know the conditions in the car to regulate the pump and to stop the filling process maybe because of different temperatures, or the container in the car is not empty, it is half full. So that means also that the pressure is different. And when you do the measurement by that devices of meters or other devices by gravimetric method, you have empty containers, and you fill each container up, and that is a completely other situation as when you refuel a car.
Okay, so in a regular filling process, the dispenser gets information from the sensors in the car, actually?
Yes.
Okay.
Yes.
And this is a wireless connection?
No,
okay.
The connection is via infrared signal through the flexible pipe and the nozzle. When you put the nozzle on the car, then you can see infrared circle.
Yeah. Okay. Thank you very much.